Hi there, my name is Gautam Jain and I am an accessibility product manager here at Workday. I'm so excited to be talking with you again today in another session of our Workday Accessibility Level Up series. If you're new to the series, each month we explore a new topic covering everything from general information and guidelines to tips on development, testing, strategy, and content creation. Whether you are new to the field or an experienced professional, we have something for you. In today's session, we will continue our discussion on designing accessible user experiences. In the previous session, we covered the importance of accessible design and specific accessibility considerations that are vital for designers to deliver an accessible product. Today, we will begin with a quick recap of our last session. Then we will delve into the remaining accessibility considerations necessary for designers to ensure an accessible user experience. Just a reminder, in our previous session, we covered the following accessibility considerations. First, avoid using colors as the only way to convey information. Check color contrast for text and interactive elements. Second, document reading and/or focus order when it differs from the visual order. Third, design interactions to work with multiple input methods. Fourth, prioritize important information in page layouts and ensure they work with browser magnification. Fifth, use sequential headings on the page. Now let's dive into understanding some more accessibility considerations for designers to ensure accessible experience for all users. The first consideration is resize text. The intent of this consideration is to ensure that size of the visually rendered text, including controls and labels using text, can be increased up to 200% by the user without losing functionality or seeing content overlap. This helps people with low vision and milder visual impairments who often increase the text size of a web page in the browser to read the content. The technical fix involves using flexible containers and relative units. Let's take a look at an example. As we can see here, doubling the base font size caused the button text to be cut off. So, what can designers do? Well, the main obstacle to text resizing is the use of fixed containers. For instance, if you create a button with the exact dimensions of 40 pixel high and 100 pixels wide, any text within it will likely spill out or be truncated when scaled up. Therefore, when designing in Figma, it is crucial to avoid fixed heights. Never specify a fixed pixel height for containers, as enlarged text will inevitably spill out. Secondly, use the auto layout feature in Figma, which ensures containers grow vertically as the text within them expands. And lastly, test breakpoints. Check how your design behaves at 200% zoom on the standard desktop resolution of 1280 pixel. The next accessibility consideration we'll talk about that is similar to resize text is reflow. Reflow means content should be viewable at 400% zoom without needing to scroll both horizontally and vertically. Reflow is essentially responsive design taken to extreme. It ensures that someone with low vision using a desktop can see the same single column layout a mobile user sees. Reflow is important because scrolling in two directions to see the content is incredibly difficult and can cause many people to lose their place, leading to increased physical and cognitive effort. Therefore, most sections of the content are expected to flow like water into a single column. However, content that requires a two-dimensional layout for functionality, such as maps, images, diagrams, video, or data tables, is exempt from this requirement. So, what can designers do with regards to reflow? Well, with designing in Figma, avoid fixed width and fixed height for content containers, as this can cause content to cut off or overflow. The auto layout with wrap feature should also be used so content drops to the next line when the width is reduced. And lastly, we recommend that designers should adopt the mobile-first approach, meaning designing with 320 pixel up to 1280 pixel screen size. Next up is target size. Target size refers to the clickable or touchable area of an interactive element like buttons, icons, or links. The Web Content Accessibility Guidelines require that these targets be large enough for users to activate them easily without accidentally hitting something else. This is required because users with dexterity limitations and those who have difficulty with fine motor movement find it difficult to accurately activate small targets when there are other targets that are too close. Therefore, providing sufficient size or sufficient spacing between targets will reduce the likelihood of accidentally activating the wrong control. So how can designers solve this? Designers should check the target size for all the interactive elements. For the web, the recommended target size is 24 by 24 pixel. For Android, it's 48 by 48 pixel. And for iOS, it's 44 by 44 pixel. In tools like Figma, use layout grids or target size plugins to verify that your components meet these thresholds. Secondly, increase the padding. Designers don't always have to make the visual icon larger. They can increase the transparent tap area or the padding around it. And thirdly, add spacing. Designers should ensure there is enough buffer between the two targets, so as a user doesn't accidentally trigger the wrong action like pressing a delete button which is placed right next to the save button in close proximity. With that, we have covered most of the size-related considerations. Let's move on to the content-related ones. The first one we'll cover is link styling. Links must be identifiable by something other than color alone. If a link is embedded within a block of text, there must be a visual cue like an underline or an icon that distinguishes it from the surrounding static text. Users with color blindness or users with low vision may struggle to perceive the subtle contrast differences between the color of the link text and the color of the body text, meaning that they miss out on important information. Hence, the most common and the effective fix is to simply keep the default underline for links within the body text. It is the most universally understood signifier for a link. If, for any reason, you absolutely must avoid underlines for link text, the link color must have a 3:1 contrast ratio against the surrounding text and provide an additional visual cue on mouse hover and on keyboard focus. And remember, style the states. Explicitly design the hover, focus, and active states. The focus state is especially critical for keyboard users, often shown as a focus ring. Don't rely on hue. Test your designs in grayscale. If you can't tell what is a link and what is normal text without color, your design isn't accessible. Next, let's talk about form labels, instructions, and errors. Forms are often where accessibility fails. Users will be blocked from completing a form if the form fields lack labels and clear instructions. Furthermore, without meaningful error messages, users will be unable to identify and fix errors to successfully submit the form. Forms with clear labels, instructions, and error messages reduce anxiety and help users with cognitive disabilities complete tasks successfully. To ensure accessibility for all users, it is expected that every input field has a permanent visible label. Placeholder text is not a substitute. Instructions for formats or mandatory fields should also stay on screen. When an error occurs, it must be descriptive and placed right next to the field. In Figma, designing accessible forms is about removing guesswork. A user should never have to wonder what an input field is for and why is it yelling at them in red. Here's how a designer should structure their form components and error states to make them accessible. Use persistent labels. A common design trend is to use placeholder text as a label to save space. This is a major accessibility failure because the label disappears once the user starts typing, taxing their short-term memory. Instead, provide a visible label for all the input fields, ideally placed above them. Additionally, any specific requirements for the field, such as date format, should be placed in close proximity to the label. Design clear error states. Using colors, especially red alone, is not enough to communicate an error, as users with red-green color blindness may not see the difference. Instead, include an error or alert icon next to the error message. Be specific. Don't just say invalid input. Use the error text to explain how to fix it. For example, Password must include at least one special character. And finally, maintain contrast ratio. Ensure your error red still meets the 4.5:1 contrast ratio against your background. Many default pure reds actually fail this on white background. That wraps up content-based accessibility considerations. Next, we will cover visual content considerations. Let's talk about images and icons first. Meaningful images and icons are vital components of modern user interfaces, but the information they convey visually must be made available to all users, especially those who cannot see the visual elements, such as users relying on screen readers. To ensure this, all non-text content that is meaningful and conveys information like photographs, illustrations, charts, graphs, and informative icons must have a text alternative. This text alternative serves as a direct, functional replacement for the image. Screen readers announce this description, allowing a user who is blind or has low vision to understand the purpose and content of the image, ensuring they receive the same information as a sighted user. Conversely, purely decorative images, which are those that serve no functional purpose and convey no meaningful information, requires no text alternative. This tells the screen reader to ignore the image, preventing unnecessary distraction or auditory clutter for the user. A good way to tell if an image is decorative is to mentally remove it from the page. Without the image, is there any loss of meaning, information, or understanding of the content? If so, the image is not decorative and should be given a text alternative. However, if there is no loss of understanding or information without the image, then that image is decorative. Now let's see best practices for designers with regards to images and icons. First, inclusion in handoff documentation. Designers should include the required text alternative for every informative image and icon directly within their design handoff documentation. This ensures that the engineering team implements meaningful text alternatives, which is vital for maintaining accessibility standards. This is an example of a well-annotated Figma design. The designer has provided the text alternative for the icons, which the developer will then use for back-end coding. Second, focus on purpose and not literal description. Text alternatives must describe the function or purpose of the visual element within the current context, rather than a literal description of what the image looks like. For example, instead of naming an image of the delete button as trash icon, use text alternatives such as delete row or remove item. Third, avoid redundant descriptors. Screen readers inherently announce that an element is an image or a graphic. Therefore, including phrases like images of, graphic, icon, or picture of in text description is redundant and can create a frustrating, overly verbose experience for a screen reader user. Next, let's discuss accessibility considerations for motion and animations. Movements can be a major distraction for many, or even a health trigger for some. For example, rapidly flashing content for more than 3 times per second can trigger seizures in users with photosensitive epilepsy. For users with vestibular disorders, large-scale motion can cause dizziness, nausea, and headaches, much like motion sickness. Accessibility with regards to motion and animation isn't about no animation. It's about providing control. To ensure fewer users are distracted by content that updates or moves, any animation that starts automatically must stop within 5 seconds, or users must be able to pause or stop it themselves. Here is an example of a carousel that automatically starts rotating when the page loads. The rotation stops when users either move keyboard focus into the carousel or hover the mouse over it, and users can manually control which slide is displayed with previous and the next slide buttons. So now, let's see what designers can do with regards to content that moves, blinks, auto-updates, or starts automatically. First, for an auto-playing video, background animation or slider include a highly visible pause or stop button. Place the control in a consistent, predictable location such as the bottom right of a video or the top right of a carousel. Second, design static-first carousels. The safest design choice is to have them stay static until the user manually activates its controls. Third, handle auto-updating content. For auto-updating content such as stock tickers, live weather feeds, or social media walls, provide a toggle to stop live updates. Last but not least, let's talk about providing feedback for user actions via status messages. A status message is a snippet of text that provides information to the user on the outcome of their action, the state of an application, or the progress of a process. The fundamental requirement for these status messages, especially in the context of accessibility, is that they must be programmatically identifiable. This means they must be implemented using appropriate ARIA attributes or by utilizing a region designed for live updates. This programmatic identification is what enables assistive technologies, most notably screen readers, to automatically recognize that new relevant information has appeared on the screen. Screen reader users specifically will receive an audible notification of a change that has occurred. For example, item added to cart, while they continue to stay in their current place on the page. For users with low vision, who often view the screen at a high magnification, they might miss a visual message appearing outside their field of view. An audible announcement of these status messages ensures they don't miss the update. To better understand this, here's an example. When you update your profile and hit Save Changes, the changes get saved without page reload, and a status message appears at the top center of the screen for the sighted users. It also gets announced via live region, informing screen reader users. However, to successfully implement these, designers need to document these expectations for developers. So, what can designers do with regards to status messages? First, define the trigger. Identify every action that doesn't result in a page refresh and decide what the resulting success or info message should say. Second, standardize notification UI. Design consistent toasts, snack bars, or banners. Make sure the text is concise. Screen reader users don't want a paragraph for a status update. Third, label the live region. Explicitly tag your notification components in your handoff notes as a live region. With that, we have reached the end of our talk today. We have covered a lot of information. So to summarize, keep the following accessibility considerations in mind when designing an experience. Check how your design behaves when the text is resized to 200%. Design up from mobile to web screen sizes to support reflow at 400% zoom. Ensure interactive elements have a minimum tap area of 24 by 24 pixel for web and follow iOS and Android conventions for mobile. Style your inline links so that they can be differentiated from surrounding text. Provide visible labels to all form inputs with instructions wherever necessary and placing meaningful error messages adjacent to input fields. Annotate meaningful images and icons with text alternatives. You also want to avoid using content that moves or updates. If content moves or updates, provide a way to pause or stop it. And finally, provide visual feedback for users' actions such as status messages. By following these best practices and using the available tools, designers can create designs that are usable and enjoyable for all users. That was the end of our presentation for today. Over the coming months, we will be having a couple more sessions focused on accessibility for designers. Future sessions will be focused on developing with accessibility in mind, testing, strategy, and mobile accessibility. With that, we would like to thank you all for attending the session today. We hope to see you next time.